All right, so in this lab, we replaced the delay loop function with a timer, so that we could incorporate the delay for any function that we needed. So we see here that I use TA1 control, which is timer one, right? We set it up so that it's in stop mode. It has a divider of three, a divider of eight, and then it's using the A clock, and we also clear it just for the start. So TA1 is the timer that we're going to be using. We also enable the interrupts for the timer module, right? So that's in our initialize function. So now let's go to our timer delay function. We pass a 32-bit integer, which contains the delay in microseconds, since we're using the piezo in with the SM clock, which is in microseconds, right? So, and we end up finding out that the A clock with a divider of 8 has a 4096 hertz period. So that gives us a 244.14 microsecond step size, right? Step time. So now we get the number of A clock steps by dividing the microseconds by 244.14, right? We see that right there. And then we get the capture compare register number of steps by just casting that to an integer, right? That may be off by one at most because of the rounding. And then we put the timer A1 into up mode, and that starts the counter. And this we immediately put the MSP 430 in low power mode 3, as that maintains the A clock on and then turns the SM clock off. So if we go to our interrupt service routine for timer A1, we see that this is just like a wake up call interrupt, and it turns off everything while it's waiting for the interrupt. We see that on that as soon as we get into it, we turn the MSP 430. We take it out of low power mode. Then we put the timer in stop mode. We clear the interrupt flag, and then we also clear the timer to reset it back to 0. Let's see. So now, just for example, we see on our function display level on LEDs, which displays a random sequence from the 0th element to the element number equal to the LED num. We see that we used to have a delay function using the delay loops, but now we have our timer delay function, which passes 500,000, which is 500,000 microseconds or equal to 0.5 seconds, so that the LED stays on for that amount of time. And then we pass 100,000 to have the LED off for 0.1 seconds using the timer. We can also see that using the counter increment, so while we're waiting to get the value for the LFSR from the first button press, we also use a timer delay with 75,000 microseconds, right? So 75 milliseconds. So very, very little for the loop. We also see down here that we have the timer delay for the 1 second delay, passes 1 million each time. We also see the low power mode again right here while we're waiting. In this part of the program, we're waiting for the user to press the next button so we can check if it's the correct button. And so we see that there. And every time that a button is pressed, right, we go to the interrupt service routine, and then we can see that we exit the low power mode 4. Even if we're not into it, we just make sure that those bits are reset correctly. And so that makes it so that whenever we are waiting and we are in low power mode, then it'll reset it. We use the timer delay also in the play losing sound function, right? We disable the buttons, and then which that just takes away the interrupt enable, and then we delay for 1.5 seconds with 1.5 million microsecond argument passed to it. Right. We see that also in the play winning melody function, which plays the winning melody. Right. We see down here the timer delay function. right? We do that for every time we have to wait for the node to finish, right? And what's good about this timer delay function is that every time we call it, we also place the MSP430 in the low power mode, right? It only leaves the A clock on, and we need the A clock to know how much time has passed. So we can't really go into any lower modes, because then that would turn off the CPU. That wouldn't let any instructions be executed. So, and that's how we have replaced the loop delay function with the clock delay function, and then that's also where we place the MSP430 in a low power mode to save energy and be more efficient.